All right, this is a hard question, and it definitely is designed to trick you, okay? So here's what most people do. They have a really good idea, okay? They think, all right, I'm going to guess and check because these instructions sound confusing. Let me see what I can do. And eventually, they end up guessing and checking with choice A. And so they think, okay, if that's X, right, that's what the choices represent, and X is 50% more than the sum of the other two numbers, well then okay, I can just take 570 and divide it by 2, and that is 285. And they say, okay, if that's the other two numbers, let's just call them Y and Z, then the sum of the three numbers plus X should be what we want, and that's going to be 855, and we know that X is equal to 570, and that checks out. 285 plus 570 is 855, but that is not the answer, okay? So the reason basically comes down to the fact that we did percentages wrong. And so even though you had a good idea to guess and check, and we can still do that, we really need to pay attention to percentages. They are a problem on the SAT. They very frequently cause us to make these kinds of mistakes because percentages aren't really reversible. All right, we saw 50%, and we kind of just, took half of the number we had and said, oh, okay, if it's 50% more then I can just divide it in half and I'll get the 50% less. And it's just not how percentages work. So if you encounter percentages, the best thing you can do is use the open formula, which is a formula I have invented because I keep seeing people make mistakes with the formulas that they already know for the SAT. Okay, so we learn about percentages in lots of different ways in school, but the SAT tends to consistently ask about them in a certain way, and the open formula is meant to keep us organized. So what it means is we have O stands for the original value, P stands for the percentage. Now, when I talk about 50% more than, we're going to talk about a percentage increase. So it's going to be either plus or minus to an original amount. So 1 plus or minus P is how we represent a change of a percentage. More about that in a second. E stands for equals and N stands for the new value. So now, the best thing with this formula is it's very intuitive, okay? If they say in the question 50% more than, then when we go to the formula, it's going to look that way. 50% more is going to be a plus, so 1 plus 50% as a decimal is 0.5. So that part is very intuitive. It's going to match with what we're told in pretty much every circumstance. Though what we do need to be careful of is where we put our X, okay? Because the X it's not the original, right? It's the result. The original is the other two numbers. So I'm going to represent that with just Y plus Z, okay? And so those two numbers are being increased by 50%, and so that's going to get us X. And so if we keep all this stuff aligned, then we're good. And we can absolutely do this question algebraically using the same formula, okay? We don't need to guess and check. I do think it's helpful. But if we do, let me just show you what's going to happen here. We're interested in finding the values of these other two numbers. I don't know what they are going to be individually. I don't care what Y is. I don't care what Z is. I only care about them as a unit. But when I do this, I'm going to need to, let's combine the like terms here. So we're going to have Y plus Z times 1.5 is equal to whatever we choose for our X. So if we do want to guess and check, we know A is wrong, but let's try B. That's kind of what I would guess and check with anyway. So my X would now be this number 513. Okay, so in order to find the other two numbers, we are going to not divide by 2, but we're going to do this weird thing where we divide by 1.5 to get those two values on their own. So, X is equal to, let's keep it as Y and Z. Y plus Z is equal to 513 divided by 1.5. That is 342. And so the sum of the numbers, the sum of three numbers is 855. So if we have two of the numbers, are 342 together, and we add in the one we just kind of were thinking about, so if we add in the X, let's do it this way, plus X, so we said X was 513, what do we get? Well, 342 plus 513 is equal to 855. Check. What we wanted, that is in fact the answer. So look, this is confusing. There's the percentages, plus there's the way that they kind of ask the question, and we have to deal with this, like these two strange sentences that we need to convert into math. So I'm going to show you how to do it algebraically, because I do think that this is a case where guess and check gets kind of messy because of the percentages, so it might not be ideal. But let's see, how would we turn this into equations from the start? Well, the first sentence, right here, that's really easy to turn into an equation, right? This sum of three numbers is 855. We can see later that one of them is x, so let's just be consistent here. Let's zoom out. That would be x plus y plus z is equal to 855. So there's my first sentence into my first equation. For the second piece, the percentage, again, we're going to need to deal with what I dealt with here. So my formula is basically still going to be this, that we need to multiply the other two numbers, which we don't know, by 1.5. So I'm going to rearrange it so things are a little bit better, but it's the same formula I came up with before. So 1.5 times y plus z is equal to x. Now we have to do something that the SAT, again, really loves to do, but we, for whatever reason, don't usually have this thought. Our instinct here, if we have a system of equations, is probably going to be to sub 1.5 times y plus z into the value for x, right? Use substitution. X is equal to this weird thing, so we plug that in for x, and then x disappears. And we can do that, and then we can distribute and whatever. But it's going to mess you up because we still have two variables. And our brains don't like that. Our brains are like, well, I want to solve for those variables. And I'll just admit it, like, we can't. There's no way to solve for y or for z. Those are going to always be a mystery. We have to think of them as a unit, okay? So what that means is we should solve for the unit. So kind of like what I did before with guess and check, my best bet here is actually to substitute not for the x, but for the unit of y plus z, right? So I can take this chunk of letters and substitute in for that. But right now, y plus z isn't alone, so I have to do a little division to get y plus z equals x over 1.5. This is confusing. And now I can substitute this in for the y plus z. We're treating these two variables kind of like they're just one variable because I don't care about them as individuals. I care about them as a unit. The SAT really likes to do this, where we make these swaps with chunks of variables, chunks of letters, not individuals. It's very common. It's not as common in school. At least I didn't experience this as much in my math classes in school. So what I'm going to end up doing to combine these two equations is I'm going to have x plus x over 1.5 is equal to 855. Okay. So a couple ways to handle it. I think the smartest thing is just the fraction is bothering me. Let's get rid of it. But either way, we're in a better place now because we have just one variable, the x. So that's going to be good for solving. So I would just multiply by 1.5 just to kind of get rid of all the fractions. So we have to distribute that. So we get 1.5x plus x equals 855 times 1.5 is 1282.5. Then we combine like terms, so we get 2.5x is equal to 1282.5. And to solve for x, we divide by 2.5, and hopefully this works. Divided by 2.5, we get that x is equal to 513. And look, if I zoom out, we got a lot of work here, but there it is. 513 is what I got originally. So yeah, we've got two options, algebra and guess and check. Figure it out. Point is, you got to know right away that that percentage is going to cause you problems. We're in the hard zone of the test, and so we should be nervous about percentages always, but especially once we get into this part of the test, it's going to be harder. And so we really need to make sure that we're on top of things and we're just being super careful.